Hello everyone and welcome to this Mistras Group webinar hosted by Hydrocarbon Engineering. The title of today's presentation is Make Your Plant More Environmentally Friendly by Reducing Flaring and Gas Leaks. And our speakers are Sam Ternelchek, Vice President for Acoustic Emission Business Development, and Lane Pinkston, Sales Operations Manager at Mistras Group. In this presentation, you can expect to learn how leak detection can support environmental initiatives and help to avoid hazardous flaring. We'll have a Q&A session at the end of the presentation, and we'd like to invite you all to submit your questions throughout the course of the webinar. For those of you that are joining us on mobile, you can access the question box by tapping the icon at the bottom of your screen. And for those of you that are using a desktop or a laptop, just click on the orange arrow on the right of your screen to open up the user interface and reveal the question box. Before we get started, I also want to let you know that everyone who is registered to attend this webinar will be emailed a full recording after today's session. So I'll now hand you over to Sam and Lane for their presentation.
Thank you, and good day, everyone. I'd like to thank you for joining the webinar today. And we'd like to talk to you a little bit about how we can use our technology, acoustic emission, to help reduce flaring and gas leaks within your plant. The flaring has become a significant cause for concern, both with environmentalists and government, as well as operating units. As the oil and gas industry undertakes different initiatives to operate environmentally friendly, obviously reducing the amount of flaring that goes on is a key element. When flaring occurs, hazardous gases are burned off to prevent releases to the environment. Also, when flaring occurs, product and resources are being wasted as they are burned off in the flare. And gases that leak through valves cause environmental concerns that plants are trying to reduce. So there's a number of issues, environmental issues, associated with flaring that industry and regulatory agencies and environmentalists are anxious to reduce and at some point possibly even minimize to zero. Just to give you an example, the International Energy Agency estimated that global efficiencies for flaring in 2020 was about 92%. So with a 92% efficiency, that means 8% of natural gases and NGLSs were not combusted and released into the environment. Obviously, this is of a concern, and the amount and the efforts to reduce this are what we're going to be discussing. Just to give you another example, flaring activities resulted in about 265 metric tons of carbon dioxide emissions in 2020. And about 8 metric tons of methane emissions. Again, these are emissions that we want to see reduced so that the effects of greenhouse gases, etc., can be reduced in the environment. And globally, 142 billion cubic meters of natural gas was flared off in 2020. To give you an idea of what that volume represents, it's enough natural gas to provide the demands of Central and South America for a year. So that's quite a bit of gas being burned off throughout the world. If we can reduce this amount of burn off, obviously there's some things to be gained besides those in the environment. There's an additional approximately $27 billion worth of funds that can be realized as a result of not burning off that gas. In addition, about 2.8 million barrels of oil equivalent are saved or available at low cost and low risk. And then reduce emissions by 1.2 billion tons of carbon dioxide per year is something that's quite significant. So how are we approaching this problem within MISTRAS? We're using or utilizing acoustic emission technology, which allows for inspection and monitoring solutions to detect and quantify through valve leakage without having to shut the operations down. So there are two different devices. One is a handheld instrument. It's used for surveys and spot checks in the field. It's a portable instrument and it's pretty convenient to use. It's because of small physical size, it doesn't restrict anyone if they need to get into confined spaces or spaces with limited access, or as we call unique testing spaces, which can be anything from a crawl space to, near the top of the stack. It's also lightweight, handheld, and battery operated. So it's a nice little tool to walk around the plant and take various measurements on valves and conduct the survey. The other tool available is a 24/7 monitoring device, which can be installed on a valve. With 24/7 monitoring, we now have available daily reports or weekly reports, however we want to generate them. It also, with this kind of approach, we can activate alarms. The alarms can be based on various parameters that are being measured or trended. In addition to the acoustic emission data, we have the ability to correlate it with operating parameters or environmental data, so that should we note an anomaly occurring, we can go back and look at the process, look at the environmental data, and try and correlate those activities detected by the valves monitor with those occurring in the environment. And with a monitoring system like this, there are different alarms levels that can be generated, and those alarms can be fairly simple local audio alarm, or more sophisticated emails or texts or direct dials, depending on the criticality of the alarm and the appropriate person that needs to be notified. So we have two different approaches. One is to walk around, take periodic measurements, trend that data, or install permanent monitors and trend the data and correlate it with the operating conditions. This is the portable instrument. It's called the VPAC-2, and as I said, it's a small, lightweight unit, weighs 1.7 pounds. It's IS certified, so we are able to use it in various areas of unit. Battery operated, there's a charger included with the unit, a couple of different sensors depending on what the application is and what the intent of the measurement is, and we'll talk about that a little bit later. It comes with a case, it comes with a waveguide. The waveguide is a device that allows it to work at higher temperatures, and again, we'll talk about that in a little bit. There's a user's manual, and there's some software then that can be used to log and trend the data. So this is the basic package for the VPAC-2, which is the portable spot check unit. And this is the continuous monitoring unit. Again, it's small size, can be used across a number of different frequency ranges, weighs 0.35 kilograms, so it's very lightweight. And this unit connects directly to DCS via the 4 to 20 milliamp loop. So all we're doing here is installing the sensor, mounting the unit next to it or in close proximity, and then running a wire back for 4 to 20 mil connection into the DCS. The DCS is then used for data logging, data trending, and data alarming. Small sensor, very small physically, and the unit is self-powered in that it gets its power via the 4 to 20 mil loop. And again, this one is IS certified too, so both units are certified intrinsically safe and used for just about any area. There are a number of benefits of having this capability within an operating unit. As we mentioned earlier, the first thing, or one of the first things, is to reduce losses to the flare. Even if there's a gas recovery system, there are savings to be had as the recovery system results in burning product and hydrogen as fuel gas. So by reducing the amount of losses going into the flare, we're saving money. It's a cost reduction, and a very notable cost reduction in some cases. It's a great maintenance planning tool. Doing a survey prior to a turnaround helps you identify which valves are the ones which really need attention during the turnaround, and which valves can be left in place and not disturbed because they're showing no indication of through valve leakage. So as a maintenance planning tool, it is an excellent device and really pays for itself the first time you do a survey. Obviously, we want to reduce losses through leaking valves that may be connected to venting system. And these are environmental issues. So again, reducing losses that get vented to the atmosphere is going to save product, and it's going to reduce the amount of contamination in the environment. That's a great troubleshooting tool also. The tool can be used to trace down leaks, and it's also very useful where you may have a situation of cross-contamination. You could have 6, 8, 10 valves on the manifold. One of them is leaking, but it's not easily detected. You don't want to tear down 10 valves. So this device is an excellent troubleshooting device that allows you to isolate which valve may be leaking and causing the cross-contamination. PSVs operate occasionally, and the question is, when they reseat, are they tight? This is an excellent device for testing PSVs after they've lifted to make sure that they are again seated and performing their function and not letting product escape. Also, ESDs have to be periodically qualified, and using this approach, we can do that requalification in a much shorter time and saving typically anywhere from 6 to 12 hours of production time. So more production time means more money, obviously. So there's a number of benefits for applying this technology, anywhere from maintenance planning for a turnaround, reducing gases to the flare, troubleshooting, requalifying PSV. There's just a whole list of things that the units are very applicable to. Pretty much any kind of damage in the valve that's going to allow product to bypass it or leak through it can be detected. The damage can be a number of different sources. It could be eroding the valve components. It could be cavitation occurring and damaging the valve. It could be deposits building up inside the valve. Just a whole number of issues that cause product to leak through a valve are detectable with this technique. It's relying on the noise of the valve leaking, and if there is a component that is allowing the valve to leak, it should be detectable with this approach. So we looked at a number of different damage mechanisms to the valve, and for the most part, all of these can be detected readily with this approach. We've had a lot of field experience with the unit, and generally we go around and make the measurements. And our experience is in a typical unit, about 5 to 10% of the valves are indicating some sort of valve leakage, through valve leakage. And again, the old small percentage gives you the biggest problems. We find that a small number of valves generally contribute about 70% of the losses. The issue here now is to find those 1 to 2% of the valves so that we can cut down on the amount of losses occurring within the unit. It's pretty sensitive. Leaks down to less than 1 liter per minute can be detectable. So we do have ability to detect fairly small leakages or through valve leakages with this unit. And leaks that exceed 1,000 liters per minute from individual valves are the real troublesome ones. So there's a variety of experiences we've gained over the years, but typically our experience shows that we need to find that 1 to 2% of the valves that are causing the majority of the leaks. This is just some example of field losses, looking at different classes of valves and assuming a certain product type. These values are based on the largest leaks per class of valves. So as you can see, the larger valve, the larger leakage, and so the larger losses. 30-inch PCV valve, an 18-inch PCV valve have quite a bit of value associated with that leak. So there is considerable amount of money that can be saved by determining which of those large valves are actually causing the leakage. When you get down to the very small ones, a 1-inch PCV valve or a 4-inch PSV valve, the amount of money is not as significant as the larger valves. However, again, there is a substantial amount of money that can be saved if, in fact, we can identify where that 1 to 2% of bad valves are and take corrective action. So looking at different size valves and the potential for savings, yeah, you could look at it and say, well, anything above a 4-inch valve, I can save a lot of money. But on the other hand, ignoring a 1-inch valve that may be experiencing leakage is still a problematic thing and has some substantial money to be saved. This is just an example of one company with multiple sites across North America. They have a total of 8 plants. They did a full survey of each plant, and across the total of 8 plants, they realized a saving of in excess of $10 million. So that's a nice little chunk of change to be saved. Just some of the examples: $500,000 in a plant in Texas, over $1 million at a plant in Illinois. The bad boy in the group was another plant in Texas that had a hydrogen valve leaking, costing close to $1 million a year just from one valve. And the total losses in that particular plant were close to $5 million. So as you can see, again, there's a substantial amount of savings to be had, and the cost of doing the survey, whether it's an internal one or an external one, is relatively small compared to the amount of savings that can be realized. Now at this point, I'm going to turn the presentation over to my teammate here, to Lane Kingston, And he's going to go into a little bit more detail on the mechanics of it and some of the experiences he's had using the instrument in the field. Lane, it's all yours.
Thank you, Sam. Yeah, as Sam mentioned, he mentioned that I had experience with the VPAC in the field. Before I was the sales operation manager, I was also advanced NDT technician in the field for about 13 years. And most of those years I was using the VPAC. So, but as you can see, here, this is just an example of turbulent flow. It's the medium escaping through an orifice creates turbulent noise. With the VPAC, it, works on steam, gas, and liquids also. If the valve is open more than 15%, the flow will most likely go back to laminar and the reading will drop at that point. So, if we know that the valve is open, we're not going to be able to use the VPAC. So we have to make sure that the valve is tightly closed, or in that closed position, and then we can tell you if it's leaking or not when we test it. As you see here, acoustic emission leak signals is detectable when Reynolds number equals 1,000. You have, the pressure and atmosphere, and then you have the diameter of the orifice, and then the flow will go through that, and it creates, the noise, and our AE sensor will pick that up. For the testing process, we, again, like I said, we ensure the valves are closed. Valve must be subject to the differential pressure of 10 psi for gases or 40 psi for liquids. If anything, these are the minimum pressures, as flow must be turbulent. If it's over that, that's great. We need to make sure we clean away the loose rust or scale on the valve. We hold the sensor on the valve body using the grease as an acoustic couplant. We let the measurement stabilize. When we take the reading, we'll give it a few seconds, and then we can enter that, take that reading. We can note it down on a spreadsheet, or we can enter it into the VPAC itself. We take the upstream and the downstream readings to check if the valve is the source. If the valve reading is the highest, the valve is leaking. If the upstream and downstream readings is higher, the valve is tight and there's no leak present. The readings only take a few seconds to generate. We close the valve and subject to differential pressure. And we hold the sensor on the body using the grease. As you can see here, there's different areas to apply the sensor, and you'll take a couple of different reasons. If this is your first time, testing the valve, you would take it in different areas to try to get the highest reading. So you would do that, like for release valve or a plug valve or ball or gate valve. If it's leaking, you take the upstream and downstream readings to confirm. Here's an example of the upstream valve and the downstream, and then you got results here. For example, if it's 13 decibels across the board, there's no leak. If you have the upstream, it is 19 and the valve is 52, and the downstream is 19, you definitely have a leak there. Another example is 62, 72, and 23. You usually take the downstream and upstream about half a meter to a meter away, depending, if you can get to it or not. Sometimes I've learned that when I'm doing my testing that, I have to reach a little further away to get a better reading, depending, it could have like pipes or something else in the way. Here's an example of our spreadsheet to calculate loss. The valves can be converted to cubic feet per minute, gallons per minute, and then dollars per hour, etc. You enter the valve ID, meter reading, the valve size, pressure, and the leak rate is calculated at that point. If you look at the spreadsheet here, we need some of this information. If you can give us the pressure differential values of the valves, the type of valve it is, and maybe even the product, and then we can go here and calculate the leak rates. If you can even give us the value of those products, we can actually calculate loss in dollars. Testing precautions, lagging and installation. Whoops, what do we have here? Hot valves may have lagging or insulation jackets on them. Just, whatever you do not remove them unless you have a permit or you have an operator to go and do that yourself. For them to do it. And user must consider any preparation of lag valves in advance of test. Never modify or cut off insulation. It may have trace hazardous material underneath, such as asbestos. Jackets must be put back on post-test and sealed properly. A lot of times what I used was the little portholes that they go in for inspections for maybe UT. I would use those if it's close to the valve or not. If not, I would have the facility go in and cut the holes or remove the insulation prior to my survey. Again, surface temperatures. Probe will operate at a temperature up to 125 C, not continuous so. For temperatures above 125 C, we used a waveguide. And that extends the signal a little bit. It keeps the heat from transferring directly onto the sensor, but there will be a loss of signal through the waveguide. When you find a leaking valve, note the reading. To get the correction for the waveguide, you would retest using the waveguide, note the reading, then you notate the difference as this gives you correction for the waveguide. However, the readings will be less sensitive and cannot be used to estimate leak rates. They can only be used as a guide. And we talk about, someone going in, doing surveys for you and stuff like that. What we try to do sometimes is combine technology with expertise. We go in, we can do a full survey. Most facilities have around 1,000 valves and bypasses that need to be tested, which can be time consuming. Over the course of a routine day, personnel may test 40 to 70 valves depending on the route and where they're located at. It could encompass approximately 4 weeks worth of testing if they have 1,000 valves. That's a lot of man hours, especially if you're an engineer and you need to stop doing what you're doing and you have to go and test the valves. That's why it's good for, to have a company come in with the VPAC like ourselves and do a full survey, maybe once a year. And then, we can tell you, which valves are in bad shape or not, or which ones are leaking. But you should also look at, if you have the unit yourself, in case you have an emergency or something's going on with the flare, you could come in, do a spot check and, test it yourself without having us come out that day. But, expertise plus the services plus the tools equals informed leak decision making. Use a tool for emergency and spot check situations, access to experienced on-site personnel for full annual surveys, and valuable time and resource savings provide peace of mind. At this point, I'm going to give you an example of a situation I encountered when I was doing a survey. This is where the expertise comes involved. I needed to go and test a valve, and when I went there, I was testing it, and the valve itself was around about 75 dB, which was pretty high. But when I went to the downstream, it was more like 85 dB. So you would look at that and you were like, okay, it's not leaking. but with my experience, something else is going on there. So what I did, I followed a downstream pipe, and about maybe 100 yards away, I kept following it down 100, 150 yards away. It brought me to a sight glass where I guess operation person was left open. I guess every once in a while they need to empty the sight glasses and let it drain to the flare, and then they close it. I guess that person forgot to close it, and once we found out where that leak was coming from, I let operations know. They went and closed it, and when I spoke to the person in charge, he said their products going to the flare dropped dramatically. I mean, they were so surprised and so excited about finding that issue, because sometimes people they open the sight glass and they might forget if they get busy doing something else. If it was left open for a couple of days, that's a lot of product going to the flare. But after that, I had to go back and retest that valve to make sure, because again, you have other noises coming from outside of the valve, downstream or even upstream, that could mask the leak of that valve. So you have to make sure that it's not coming from somewhere else. The summary is reducing flaring starts with the right solution. Field inspection and online monitoring tools enable plants to detect and quantify through valve leaks that may result in flaring. Using through valve leak detection tools, you can help achieve your environmental initiatives. Leak detection serves as an excellent troubleshooting tool for tracing leaks and source contamination, which can have an adverse impact on the environment. ROI can be realized quickly. And internal promotions of systems, a leaking PSV was losing 0.0 mm SCEF per day or 300,000 PA. Savings of 400,000 was achieved using systems to satisfy safety cases for ESDVs. And that's it for our presentation.
Great, thank you very much for that interesting presentation, Sam and Lane. We're now going to move on to the Q&A session. So if you have a burning question for our speakers today, now is the time to send it over to us. As a quick reminder, if you are using a mobile, you can access the question box by tapping the icon at the bottom of your screen. And for those of you that are using a desktop or a laptop, you can go ahead and click on the orange arrow on the right of your screen to open up the user interface, and you can then type your question into the box. Okay, Sam and Lane, I'm going to kick off with a question I have. Lane, I was hoping that you could help me with this. I was wondering what type of valves can be tested with the kinds of solutions that were discussed in this webinar?
Well, let me see if I think we have this on the sheet here, and before I answer the question, I'll bring it back up to that slide. Okay, right now, we can test all different types of valves. It's different sizes. We have plug valves, gate valves, ball, clove, butterfly, RV plugs, PSVs, PCVs, even the bypasses. So there's all types of valves that we can test.
Okay, brilliant. Thank you for that, Lane. Another quick question for you. Data security is obviously paramount at the moment, and it's something that we get asked about all the time. So I was wondering, how do you store the data that is taken with the instruments?
Well, what we do is, the instruments can store, up to like 50 valves at a time in a route. And, each valve requires 3 measurements and other information field, like the serial number, the name, the pressure, inlet size, valve type, valve seat type, equations and stuff like that. to set this these fields up to generate the data based on the collection of the valve over time, the system is sold with a software called VPAC Win. This software can be installed on any PC running Windows 7 and above. At that point, you would go in and interact. And when you go with the VPAC and you save all that data into the VPAC, you would take it back to your laptop, plug it in, connect it using Bluetooth, and then you would transfer that data from the VPAC itself to the software. And at that point, it would enter all the data into the software. Let me see if I can pull that up here. And it would generate your leak rates for you. And you see here.
Okay, brilliant. Thank you, Lane. We've had a question come in from Nicholas Dunn that you may have touched upon, Lane, at the end of your presentation there. But the question is, he wants to know how accurate the leak rate calculation of the valves is.
I'm going to let Sam answer that one, if that's okay.
The way the algorithm was developed, it used empirical data, and the solution is a best fit straight line for the various different conditions that are experienced in the different valves, etc. But as a rule of thumb, we typically use 5 to 10% as the accuracy value. And so what we developed in the analysis is a best fit result applied to a large database of data from all different kinds of valves, all different mediums, all different pressures, and also whether it was liquid or gas. And so because of the large variance in the database, the solution is a best fit solution with an accuracy of about 5 to 10%.
Great, thank you, Sam. So another question that we've had come in is asking, is it possible to use the data calculated with the leak detection tool as a formal report for the environmental authorities and thus declare a reduction in gas emissions?
We've had that request several times. Unfortunately, because of the accuracy at 5 to 10%, it's not always accepted as a loss rate measurement tool. So there are some limitations in quantifying it in that regard.
Okay, thank you, Sam. So we've still got time for a few more questions. So if you've got a question for us, get it over to us now, and we'll try and get through a couple more before we end today. Sam, while I've got you, I have a quick question about what types of fluids can these solutions that you mentioned in your webinar be used on?
Pretty much all types of fluids. We've used it on various process fluids. We use it on fluids where you have a gas and a fluid. Pretty much anything that can squirt through the hole, so to speak.
Okay, brilliant. So I think we're coming to the end now. So Sam and Lane, before we draw a close to this, I was just wondering if you had any closing comments or anything that you'd like to add.
Well, again, from my experience in utilizing the tool, it's just such a valuable instrument for pre-turnaround testing, really finding which are the culprit valves that need to have attention during turnaround. And as a troubleshooting device, it's an excellent tool to have on site when you have these problems of cross-contamination or multiple valves in a system. It really does a good job in finding which one may be leaking.
Okay.
Right, and I would like to make another point. There was another situation where I was at another facility. You know, a lot of people are like, "Oh, my valves are not leaking," you know, because they're so small. You know, we're not getting any issues with our flare. You know, it's just burning. Everything looks good. But you know, a lot of times when you go in, you'll be surprised. You know what we do find. Like for example. You know, I was going to an area of the plant and I said, look, you know, there's a valve there. I need to go check. And I was telling the operations person I was with, I need to go in there. And he said, that's HF area. I said, well, I need to get suited up and I need to go in and test that valve. He said, oh, that valve's brand new. You know, it shouldn't be tested. We're not worried about that. I said, well, I need to test it anyway. And I actually go in, get suited up, and go into that area, and I test the valve, and we come to find out it was actually leaking. And they were so surprised that, you know, a brand new valve would be leaking like that. So it does happen. And, you know, just because you think, you know, your valves are not leaking, you'll be surprised to what you find out. So that's all for me.
Great, thanks, Lane. I think that's got us all thinking there at the end. So a big thank you, Sam and Lane, for taking the time to answer those questions for us and for your interesting presentation. If you have any further questions for the team at Mistras Group, you can reach out to them directly. Their email address is on your screen now, so it's sales@mistrasgroup.com, or you can head over to their website, mistrasgroup.com, for more information. And before we finish, a final reminder that everyone who has signed up to attend this webinar today will shortly receive a copy of the presentation via email. So thanks again for joining us.